You're going to stand in the background?
Yeah.
Okay. Goodness. Okay. So, the replication crisis in the sciences first came to my attention because of the book that I've assigned for critical thinking and I've been using for the past 5 years or so. I noticed that some of the studies that Kahneman cites have recently been unable to be replicated. So, and I mean, it means that the phenomena aren't really real. For example, in chapter 3, The Lazy Controller, Kahneman talks about something called ego depletion. Silly. So it turns out that's not a thing. Willpower doesn't run out as you use it. Massive numbers of scientific studies have failed to replicate. And reports where scientists have studied this failure of replication have shown that either the originals could not be replicated at all, or the effects were much weaker than originally reported. So here's some famous examples of failed studies. There are a few in your textbook, Thinking Fast and Slow. I did not assign chapters with those errors in them. Yes, Wolf. Oh, you want to sit in my lap? Posing like Superwoman will make you feel like Superwoman is what the TED Talk's about. You can go and watch that, but it turns out that was not able to be replicated. She calls it power posing. The marshmallow experiment is a much older experiment, and that was a big relief to me to find out that study was not able to be replicated. The marshmallow experiment said that little kids who were able to resist eating one marshmallow now in order to get 2 marshmallows later. And here's some other ones. So Kahneman talks about I think it's in the first part of the book, maybe chapter 8, that being exposed to certain words like, I don't know, arthritis, hobble, cane, walker, healthy participants would leave the study and walk down the hall more elderly-like. Turns out that was not able to be replicated. This has always concerned me, living in Las Vegas. There was a study that supposedly showed that looking at pictures of money would make you more greedy. Turns out that's not true. Looking at pictures of money does not make you more greedy, thank goodness. And then this one, there was a study where they had people that believed in God to look at the statue, The Thinker by Rodin. And the study reported that groups that looked at the statue of the Thinker versus another statue made them less likely to believe in God. Turned out that was not able to be replicated. So I'd like to tell you the good news. This is what I don't want you to walk away with. Thinking that science is unreliable and you can't trust anything scientists say, and even if it's in a peer-reviewed journal, it's no good, and I'm just going to be skeptical about everything. That is not what I want you to take away from this. Okay. So, not all of science is implicated by not all of scientific research, I should say, is implicated by the replication crisis. The scientific disciplines that depend most heavily on statistical analysis are most affected. In the chapter on the law of small numbers, which you've already read, Kahneman even says, I was embarrassed. Most of my colleagues were performing experiments where there was a 50% chance that from just the numbers they used, the size of the sample, there's a 50% chance that they would get a false negative, that they couldn't prove anything with those numbers. And Kahneman says, I was doing the same thing, and I'm really embarrassed about it because I was teaching statistics at the time. Finally, and this is the biggest part of the good news, science is self-correcting. So it's not like outsiders to science, said, oh, you're a bunch of frauds, you're making up your results. That's not what happened here. Scientists themselves tried to replicate other scientists' studies and said, oh, wow, I can't replicate this, and kind of raised warning flags. These warning flags built up, and other scientists said, oh, how common is this? So scientists self-correcting, meaning that scientists themselves are scrutinizing their own work and correcting their own errors. So this is one of my sources, Aubrey Clayton. So he's a mathematician turned philosopher, and kind of put his finger on this issue when he was getting his PhD in math, focusing on probability, when he asked himself the question, what is probability anyway? What are we even talking about? So he was asking a fundamental question about how the math maps onto the actual world. Okay, and that's how the methods of modern statistics, he writes, are founded on a logical error. These methods are not wrong in a minor way. They are simply and irredeemably wrong. So the statistical analysis. Okay, next one. Okay, so what's wrong with statistical analysis? So it turns out that that was originally developed to predict odds for gambling. And it does. It works great for gambling. And this is the logical difference. You know you're rolling, suppose, 2 dice, and each dice has 6 sides. And each of the sides have numbers 1 through 6 on them. You know that, and from that, you can predict the odds of rolling a 2, a 7, a 9, a 12 from that initial, the description of the initial conditions. You can work out those probabilities. This is hard to see, hard to understand. And if you have trouble grasping it, don't feel bad, because people like Daniel Kahneman, who has a Nobel Prize in economics, did not see it either. Okay. So the logic that underlies frequentist statistics, those are statistics that tell you how likely it is the next card you draw from the deck will be an ace, does not track the reality that scientists want it to track or are expecting it to track. The logic doesn't work because the order is in the wrong direction. And you all studied in deductive logic, in if-then statements, it really matters which is the antecedent and which is the consequent. And if you get them mixed up, you'll end up with a logical fallacy, like affirming the consequent or denying the antecedent. Okay. We need to start with the data, and say, given this data, what reasonable inferences can we draw? Okay, so look, this one, going from hypothesis to data, is, I'd say, descriptive, and this is explanatory. So this says, what is the best explanation for the data I have? This one up here, I hope you can see my cursor. This one here starts with, this is my theory, what data should I expect? Okay, superficially they sound similar, but there's a huge difference. Okay, so the first, as I just said, is a prediction of frequency. The second is an inferential judgment. It's an inference claim. So the logical connection between the data and the theory, the data and the hypothesis, is fundamentally different. They're measuring 2 different things. So the first one, hypothesis data, given the parameters of this gambling game, what outcome should we expect? Versus, given these observations, what should we conclude about the laws of math? So this woman, Sally Clark, had 2 babies die suddenly of SIDS, sudden infant death syndrome. So the expert witness said, what are the odds that these 2 babies would just die by chance? And the answer is, and this is the real answer, very, very, very unlikely to have 2 babies die independently of each other. So it's not like they both died in a car crash. The odds are astronomical. And based on this argument, Sally Clark was convicted of 2 counts of murder, and she served 3 years in prison before she was exonerated, and different statistical societies came out and said this reasoning is flawed. So this is where this makes all the difference. You're getting accused. How is this statistical frequency versus like an inference? Why is this important? Well, it made the difference for this person being in prison for 3 years and accused of murder. What she was convicted on, like, how likely is it that this would happen? Instead of this question, which is the explanatory question. So given the state we're in now, given the data, we're in court because 2 babies have died. And then you need to compare that. Are there any other explanations for the death of these 2 babies? Given that 2 babies died, what do the odds they died of murder? All right. Compare the 2. Is it more likely that if you have on your hands 2 infant deaths, is it more likely that the cause of those deaths were murder or sudden infant death syndrome? And of course, I shouldn't say of course, I mean, it's thankfully, parents don't murder their baby. It doesn't happen very often. It's very rare. SIDS is a much more likely cause of death. Poor Sally Clark was exonerated, but she never was the same again after losing 2 kids, being falsely accused of murder, losing everything, and being in jail for 3 years. So what science can I trust? All right. So first, studies that have been replicated. Scientific results that have been confirmed by multiple scientific organizations or scientists in different cultures, different countries, different languages, countries and languages, yeah. So if you find independent studies coming out in India and United States and Canada and Belgium that all say very similar things, that's trustworthy, passes the bar. Again, and then also results that are supported by different scientific disciplines. What scientists can I trust? I would be skeptical of any science that relies exclusively or mostly on statistical significance testing. So these are going to be studies that say, oh, we mined all this data and we found a correlation between yawning and Alzheimer's. A study like that. People who yawn more than 3 times a day are more likely to get Alzheimer's. That's just correlating to properties in the population, and that's much more likely to get a false positive. If that's all it is, you're just looking at, a genetic, a gene in the human genome and some trait, and they're linking these through statistics. That is something to be skeptical of. And then finally, what science can I trust? I would be skeptical of studies that are conducted by special interest groups. There's something called the funding bias, where the person or the industry that is paying you, I heard this study was crazy. The industry that's paying you, Coca-Cola, to study the health benefits risk of drinking Coke is going to guess what? If Coke is paying for it, going to find that drinking Coke is good for you. And the person I heard interviewed was saying that, like, if you don't have a safe water source, Coke is better than drinking contaminated water. But of course it wasn't, which is true, right? If you don't have anything to drink and you have a choice between sewage water or Coca-Cola is much healthier. But yeah, the Coke representative did not say it quite like that. Okay. Yeah, and another note,